So in this video, I want to record a quick example of me working out a multiplication problem using the sort of negative numerals that Cajori mentions and attributes to Colson in paragraph 90 of the History of Mathematical Notations. He gives an example there, and actually there's a typo in that example, which makes it a bit tricky at first. But I thought it's rather large, using rather large numbers, which certainly one of the advantage of the method is that it works with these very large numbers. But I thought to help understand how the method works, it might be nice to see it done with a slightly smaller example. So the primary idea of the method is that we can reduce the magnitude of the numerals used if we allow ourselves to use numerals which are possibly negative. So for example, the first step in this multiplication problem would be to convert each of these numbers into expressions that use only the numerals -4 through 5. So when I look at, for example, 993, so I start from left to right and I say, okay, well, 3 is fine, that's an acceptable numeral, but 9 is not. So I would like to convert 9 by subtracting 10 from it. But if I'm going to subtract 10 here, then essentially that's 10 tens. So I'm actually subtracting 100. I need to add 100 here in order to keep the number the same value. So I'm going to convert this into -1, which in the book was notated historically as 1 with this line over it. But since I have subtracted essentially 100 here, I need to add 100 here. So instead of 9 hundreds, I'll now have 10 hundreds or 1,000. Okay. So this becomes an equivalent representation for the number 993. Now I will multiply by 126. Now again, here I'm going to start by looking at 6 and saying, well, that's not one of my acceptable numerals. And so I'm going to need to subtract 10 from that. When I subtract 10 from 6, that'll give me -4. Okay. But I have now subtracted 10 here, so I need to add a 10 into this digit, which will become 3, and then the 1 is still fine. Okay. So I've now sort of equivalently rewritten this problem, which was 993 times 126, as this 1, 0, -1, 3 times 1, 3, -4. Now, the fundamental idea here is then to, and the book, Cajori sort of explains this, but I should take each of these numerals and write them on sheets of paper. So give me 1 second, I'm going to do that, and then we'll come back. So as you can see now, I have my two numbers written on these two slips of paper. And what I'm going to do is I'm going to take the second number here, and I'm going to take it and I'm going to bring it up here and invert it like this. And I'm going to start by lining these up. Make sure you can see this. So that sort of the first, right, if I sort of think of bringing these together, the first digits overlap. And so I'm going to start here this multiplication process by observing that 1 times 1 is 1. And I'm going to write that on the first line here. Now I'm going to move things to the, move. You can think of this as either moving the bottom slip of paper to the left or the top slip of paper to the right. And now the next thing I'm going to compute is 1 times 0. That's 0, plus 3 times 1, which is 3. So again, I'm doing 1 times 0, 3 times 1. That gives me 3. Now I slide again. Okay. Now I have 1 times -1. That's -1. 3 times 0 is 0. And -4 times 1 is -4. So I have -1 plus -4. That's -5. Now notice each time I'm going down a line, but I'm also moving over one sort of place in terms of place value. All right, I slide again. Now I get 3, -3 and -4, or sorry, 3, -3, and 0. That all adds together to be 0. Slide one more. 3 times 3 is 9. -4 times -1 is 4. So I get 9 plus 4, which is 13. Now, I'm going to record the units digit of that to the right, but now this will go under the previous value. Now I move one more time. The only thing that overlaps here, I have a -4 times a 3. That's -12. So again, the units digit of that goes one place over, but then the tens place goes under the previous entry. Okay. Now what I'm going to do is I'm going to take and I'm going to sum each of these in terms of place. So I have a -2. Then I have a 3 plus -1, that's a 2. I have a 0 plus 1, that's a 1. I have a -5. I have a 3. And I have a 1. Okay. And this ostensibly should be my answer, but notice, right, it's not sort of written in the form that I'm used to writing numbers in. So what I'm going to do is I'm going to convert this back. So I need to sort of get rid of these negative numerals. So in this case, to do this, I'm going to sort of work back from left to right. So the first negative numeral I have is this 5. I'd like to add 10 to this, but in order to do that, I need to borrow 1 from here. Okay, so this would give me, I'm going to borrow 1 from the 3. That'll give me 10 plus -5 here gives me 5. 1. Now I'm going to need to borrow from this 2 here so that I can add 10 to the 2 here. That gives me 1. And when I add 10 there, I get an 8. So at the end of the day, what I get is that the product of 933 times 126 is 125,118. Now compare this, if you will, to the usual standard algorithm for multiplication. Right, 993 times 126. Right, it'll give you the same answer. I'm not going to write out all the details, but you're going to have to do sort of a lot more arithmetic because you have larger in magnitude numerals. Right here, the largest sort of addition we had to do was 3 plus -1, whereas you can already imagine here you're going to get 18, then you're going to get 54 plus 1. I mean, the magnitudes of the numbers become much larger to deal with and just make it slightly more tricky. So this is just a brief example to walk you through explaining how to do this, and you'll have an opportunity to practice this on your own shortly.